sine, cos, and tan, sin, cos, tan. And above them, you should have, and I will zoom in a little bit or just bring my calculator up to you, right? You should see sine with a little -1 above sin. Okay, Benedict, I got you now. And cosine, right? You look at the button cosine and just above it, you'll see cosine with a -1 on top. That's what we call the inverse. And then there's tangent, and you have tangent with a -1 on top. Okay, so those three are called inverse functions. So you've got your regular trig functions or trig ratios. It's sin, cos, tan, sine, cosine, tan, and your the inverse functions are just above them. Practice with me. To access them, you press Shift or second F, right? Second function. Okay, I got Benedict and Christopher. Reggie, I just saw you showing up again. Are you here? I'm just making sure you're actually looking at the screen. Let me know if you're here. Okay, good. So to access the inverse, okay, everybody, you press Shift or second F or something that allows you to access. So if I press Shift, immediately there's a little S on the top screen there. It's hard to see, but it's there. And as soon as you press sine, you should have the inverse show up like this if you have a two-line calculator. If you don't, let me show you one that doesn't. This one here, for example. I don't know if it's, oh, it's dead. Never mind. Oh, no, there it works. This one has a second function as well, like a second like that. If I press second, the battery is so low that every time I press something, it'll just die on me. Okay, so you're gonna have to try something. Anyway, so second, and then sin, cos, tan would be right here. So you have the inverse functions right above them. So you do it the same way. However, the way you enter it is gonna be backwards. So we're gonna try to help you out there with that to figure that out. Anyway, so when I talk inverse, I'm talking sine, cosine, tan with a little -1 above them. Okay, it's not a power, so don't think it's power to -1. It is just that. Okay, so let's start taking notes. In previous lessons, we learned how to calculate or solve for unknown sides using trig functions, sin, cos, and tan. That's for short, right? In today's lesson, we will learn how to use the inverse trig functions to solve for angles. That's what the plan is for today. I will give you the steps and then we're going to go through those steps together. Okay, so here we go. Steps. And it's probably in your best interest to have the steps on your study sheet together with maybe at least one example right next to it on how you do it. And you can copy one of the examples that I'm about to give you to do that, okay? So first question, or first step would be find the reference angle, okay? Find the reference angle, and that is the one you want to find or solve for, okay? That is the first step. Step 2, label two known sides. Step 2 would be label two known sides. You're not trying to find sides here, you're trying to find an unknown angle, okay? 3, determine which ratio to use. So you have to kind of narrow it down, right? Is it a CA scenario or is it a TOA scenario, right? And that will narrow it down. Only one, you will only be able to use one. Okay, and that will be determined by the two sides that you label. And setup, right? And the setup will look something like, I don't want to give you an example here because then you're going to think it's always sine or always cosine. So I'm just going to say setup and then 5, convert fraction to decimal. You want 4 places minimum, preferably all of them, but 4 minimum. Gurjot, you're there? Okay. 1 o'clock. Okay, 5 is that, and then 6. Calculate the angle using the inverse. I will make inverse capital because that is key. It's almost like the square root in Pythagorean theorem. I find that a lot of students forget to take that last step of the inverse. So we'll make it nice and legible. Okay, inverse. Capitalize all of them. So those are your 6 steps, which after a while, it seems a little overwhelming, but after a while, you're just gonna, it's gonna be done in like 3 lines. Basically, your work is gonna be 3 lines and then you're done, okay, when it comes to finding angles. So don't let it overwhelm you too much. Note, each trig function. So when I'm say trig function or trig ratios, I'm talking about sine, cosine, and tan. Each trig function has its inverse. So sine has sine inverse like this. Cosine has cosine inverse like that. Tangent has its inverse tan then -1. Okay, so every single one, sine, cosine, tan, has its own inverse. Okay, it won't always be sine or always be cosine. Depends on the situation. So it's imperative that, right, you have these notes written down so that because this is somewhat new. Okay, word problems, you know, I do quite a few, I've done quite a few. If you missed one or two here and there, it won't affect you as much. Ideally, you don't want to miss a single one, but right, but this is brand new, so you want to go back once I post the video. If you missed the first couple of lines, and update that in your notes. Okay, it's very important. You're gonna forget if you don't. Okay. Um, there it is. So sine, cosine, tan. And so now we're going to do some math, okay, practicing. So calculate the value of angle A for the following. FF stands for the following. So A here, if I gave you sine of A, and notice that a angle could be a capital letter, or it could be theta, which is that circle with a line in between, just also a letter, but it's a Greek letter. So it depends on the worksheet that you get. So if you have sine of A and you get 0.5, that's going to be the first question here. B, we're going to do that right next to it. Cosine of A is 0.7359. And C, we're going to put that down here. Tangent of A is 1.3492. So I'm kind of fast forwarding to don't ask right now about the test or anything. I did mention it earlier, right? Earlier this last week. So go ahead, Patrick, do what you need to do and then join us. The test, I believe, I have to check right now. I have it in my calendar. I thought it was the 25th. I would have to check that to be 100%. It's when you're back. Okay, you come back to write that. I'm gonna have it booked in the cafeteria, I believe. Okay. Yeah, I now need you to grab your calculators and follow along. Okay. Um, I hope it's not choppy for everybody. I hope it's you can hear and see me properly. Can you just reply, you know, from a scale from 1 to 5, what's the audio and video like? So just write down 1, 2, 3, 4, or 5 and just put it in the chat. Okay, some 4s, some 5s, 3, 5, 5, 4, 4. So it's mainly 4s and 5s. Okay, that's good to know. I don't know what to say if it's worse than I hope a 3 is still okay, Carter. I hope you can still pick me up. Okay. All right. Thank you for the feedback, guys. I appreciate that. Okay, let's go back here. If you have something like this is basically going to be like the second last line when we do a full-on problem, okay? So I'm fast forwarding to that point right now just because I need you to practice using the inverse. So if sine of angle A is 0.5, what is angle A? And this is how I want you to write it, okay? Okay, good, Carter. Good to hear. Follow me here. You write down angle A like that. Sine is going to be gone. but it appears over here as the inverse. You take the inverse of whatever decimal is on the other side, and usually it's in brackets like that because your calculator is going to put it in brackets to begin with, right? As soon as you go sign inverse, it's going to open up with bracket and asking you for an input, which is that decimal. Just make sure you close it when you're done. And then your last line is now, what is the angle? So here's my calculator. I would go shift sign, whatever you need to do to bring that inverse out. And mine doesn't have brackets, I just go 0.5, and I get 30. In this case, it's exactly 30. And so the angle in this case would be 30 degrees. So you write down 30 degrees. So you're almost going backwards, right? Like it, and we will do a bunch of examples and hopefully it will make more sense to you. B, cosine of A is 0.7359. So there's a decimal that has 4 places. It could have as many as you want, okay? So angle A in this case, and notice that this could be A, B, C, Z, whatever, but we're using A in this case, would be, since it's cosine of A, you would have to use cosine inverse of 0.7359. And you can put it in brackets, you don't have to. And that's, now we're going to find out what angle A is. So you're going to go second cos or shift cos, whatever. And I have brackets, so I'll put them down. Why not? 0.7359. And you close the bracket and you get 42.62. And it's degrees. Make sure you understand that as soon as you use the inverse, you're going to have to put degrees down for your final answer. It's not meters, centimeters, miles, yards, ever. It's degrees, okay? Make sure it's always degrees. And this one here, tan of A is 1.3492. So A would be tan inverse. Why tan inverse, Mr. Dirksen? Because there was a tan here. So whatever you start off with, that's the inverse you're using. And you have to be set to degrees. If not, you're not going to get the same answers as I do. So here we go. Shift tan 1.3492 and hit equal. I would encourage you to quickly try that as well, and you get 53.45 degrees. And last one. Here, D. Cosine of A, we have to use A because we started with A, is 3/7, like that. What if you got something like that, 3/7? That's not a decimal, is it, Mr. Dirksen? No, it's not. So when you have this, turn it into a decimal right away. So 3 divided by 7, that gives you 0.42. So we're just going to go, this is the same thing as saying 0.4286 because the 7 bumps that 5 to a 6. So 4286. Okay. So I have to add a step where I convert the fraction to a decimal. And then you're going to do the same thing. A is equal to, we started with cosine, so I'm going to have to go cosine inverse of 0.4286. Mr. Dixon, could I have just put the 3 divided by 7 in here? Yes, you could have. That's fine. So I'm going to go second cosine of 0.4286, and that gives me an angle of 64.62 degrees. And notice that I'm going to highlight the degrees symbols here. I don't know if that makes a big difference for you, but right, I'll make a note here. When using inverse, your answer is in degrees. Okay, make a note of that. All right, so now let's deal with some triangles here. Let me pause that, just making sure. So here we have, I'm gonna make sure my original notes are following them. Solve for the unknown angle. And I'm going to put down two sides given. Solve for the unknown angle, and this is the case. These cases are going to be where only two sides are given to you, okay? So first question. .5 inches, 6.5 inches, and they want this angle right here. I'm going to put an X to it there. Second question here. .5 yards, and this is 12.8 yards. And we're going to put the unknown angle here. So remember, angle measures the opening between two sides, right? So let's just stick with A and B for now, write them down, and then we will solve them. Or not solve the triangle, because solving the triangle means solving all angles, all sides, right? Make sure you have those written down. So obviously when it's a diagram, it's a little easier when the diagram is provided. Okay, so if you've copied this, great. So if you go through the steps that I gave you, I'm going to try to stick with those steps to find the reference angle. So this is your reference angle, because that's the angle that is unknown. So you position yourself at this corner, this vertex here. All right, and you're trying to find what the opening is there. So that's step one. Step two, label the two known sides. So coming out from this angle, this be considered the opposite side, and across the 90, that be considered the hypotenuse. Okay, so don't worry about the one that you don't know. Okay, you're just gonna pick the two that are, and it's based on this reference angle. Determine which ratio to use. Okay, so that'd be step three. So out of so, ka, and toa, so it's the same thing basically at the beginning, right? It's O and H, so you'll have to use sine. Okay, determine which one to use. We said sine. Then set up. So I'm going to use that to help me set it up. So sine of what? of an angle. If you don't know what the angle is, if there's only a question mark, you can just use A, right? So sine of x is technically a capital X, okay? Sine of angle x. Remember, sine always needs to have an angle glued to it. It could be a letter, it could be a number, okay? In this case, it's a letter because it's unknown. Equals, in that order, you put a line, right? Opposite is 1.5. Hypotenuse, which is supposed to go on the bottom, is 6.5. So I don't know if you start noticing, it's like, oh yeah, we just saw that, right? Yes. So setup is done. And then it says convert fraction to decimal. So we're going to convert this one into a decimal up to 4 decimals, that is. So you want to get rid of the fraction. So you just go top divided by bottom, right? I don't know if you remember that. If you divide top divided by bottom, you get the decimal. So that'd be 0.2308 because the 6 beside the 7 bumps it up to an 8. So 2308. You can do it right next to it if you'd like. So you convert that. So these are actually true, right? All 3 of these are the same, except for we're not going to forget about that fraction and just deal with the decimal, okay? So the next step here would be saying, hey, angle x is equal to, and we're using sine. You're going to take the inverse sine of that, of 0.2308. Okay, so it disappears here, comes over here with a little -1 on top. Now you can find out what x is. You can either use all the decimals, in which case, like I still have them on my calculator, in which case your answer might be slightly different, but you're not going to lose marks. So I'm going to clear my screen. I'm going to use shift sine of 0.308. Some of you might have to type in 0.2308 first and then go shift sine. So you have to do it backwards. And that is 13.34 degrees. It's degrees now, okay? Oops. 13.34 degrees. If you get an error at this point, like I'll make one for you. I'll make it give me an error here. You're gonna get a math error or something. And what that means is that you probably made a mistake up here in labeling, or you made a mistake in where you put the sides in. So you got to make sure that that is correct. Okay. So we solved that one. Let's solve this one here. Okay. Or we solve for the angle. So you now know that this opening is 13.34 degrees. So if you think about it, it's actually a very small angle, right? So this triangle would be actually very flat if you were to actually draw it to scale. Okay, none of these is drawn to scale. So here we go. Second triangle. Reference angles there. Label the 2 known sides. This is opposite. You don't care about. Hypotenuse, adjacent. Okay. So then it's A and H. So you know it's supposed to be. I'm gonna do this for notes here. I'm gonna do this anyways. Okay. Don't be too confident, right? Some of you just want to cut to the chase. You're too confident, then you make mistakes. Okay. Cosine is what we're using here. Cosine of what? In this case, it's x is equal to, it's asking for adjacent, so it's 3.5 over hypotenuse, which is 12.8. You don't need to put the units down because the units cancel out anyways, right? If you have yards and yards, you can cancel them out. And so next step is to convert that into just 1 decimal. So you're going to go 3.5 divided by 12.8. That's 0.2734, right? The 4 does not get changed because you have a value less than 5 next to it. So x is going to be cosine of -1, 0.2734. So it's inverse cosine of the decimal you just found. So you're going to go shift cos 0.2734, and that's 74.13 degrees. All right. So there you have it. One example here. So we're going to do this one and then one more, and then it's going to be up to you to do some work on this. Okay. Draw your triangle. We're going to have a question mark here. This is 24.3 kilometers. This is 28.9 kilometers. And so they ask us to find that angle here. So this is the opening that we're trying to find the measure for. Okay. All right. So you can tell that, my videos right now 32 minutes. So try to keep it at around 40, 45, right, for today. So here is the reference angle, because that's the one they want you to find. You label, you drive out, that's opposite. This will be the hypotenuse here, you don't care about it. So you just label opposite and adjacent. And you write down SOHCAHTOA. O and A and O is here, right? You use this to guide you. So tan of, you need a letter for angle. Why not use capital A? Opposite is 28.9 divided by 24.3. Let's get this into one decimal. That's 1.1893. Angle A is going to be tan inverse of 1.1893. And that's 49.94 degrees. Regardless of what worksheets do or say, round to 2 decimals, right? Even if the worksheet says round to nearest 10th, we're going to round to nearest 100th no matter what, because that's what the provincial exam always does in grade 12, right? They always want you to round everything to 2 decimals. Okay, so we've done a sine, cos, and tan, always taking the inverse at the end. How do you know which one to use? Just like before, you label, and it's the two sides that are involved that narrow it down. Okay, next here. Yeah, go ahead, Francis. How you as long as it's done correctly, if you round to more than what they require, then actually no, we don't take marks off. Yeah, good question. All right, let's keep going. Last example for today. What if What if more than two sides are given? So what would you do in that case if all three sides in a triangle are known, right? How would you do that? Well, the answer is you only label two sides of your choice. And that's where students kind of, they don't like that. It's like, what? I have the choice, right? Yeah. The beauty is, regardless of which two you pick, the final answer is the same. Okay, the final answer is still the same. So, example, so let's say you have a triangle like this. You know this is 3.6 centimeters. You know this is 6.0 centimeters. This is 4.8 centimeters, like that. And they're asking you to find this angle in that corner there. How would you do that? Okay. So all three sides are given, meaning like now you need to narrow it down to just two sides, right? So what I will do here is, this is my reference angle. Okay. I'll wait a little bit, make sure you have it written down. All right. So this is your reference angle. You pick two sides, any two. Just make sure you label them correctly. So let's say I go across and go, this is opposite. Across the 90 is the hypotenuse. Done. So what about this third side, Mr. Dirksen? You almost want to like cover it up and not worry about it. So O and H, you got to use so, right? It's a sine example. So we're going to go sine of, we're going to give that a letter, any of your choice. I usually pick A. Sine of angle A is opposite over hypotenuse. I figure out what that is as a decimal, and that is 0.8. Exactly. Boom. Right? Bang on. Therefore, angle A, since I'm using sine, is going to be sine inverse of 0.8. And what do we get? 53.13 degrees. Okay? 53.13 degrees. Done. Okay? However, I want you to see that no matter which ones you pick are the ones that are going to work, right? So let's say I'm going to go ahead and label this one as well. This would be the adjacent. Let's say you did not label the hypotenuse, you just labeled the opposite and adjacent. So you kind of want to forget about these, the hypotenuse, and just consider these two. So if it's opposite and adjacent that you've labeled, then it is, and you're all saying TOA, right? Tangent, yes. So you would go tangent of angle A is going to be opposite over adjacent, like that. You go turn that into a decimal. You get 1.333 and it keeps on going. Round it to 4, it stops there. A is tan inverse of 1.3333. A will be 53.13 0.13 degrees. And I think we're gonna stop. We're not gonna do cosine yet because I think you trust me at this point, right? The key is don't label all three, just label two of your choice, go with it, and you will get the answer. Okay, so if that ever happens, no big deal, you know what to do, right? And right now I will ask you to do this. Okay, work on inverse trig ratios worksheet, and I'll show you what it looks like. If you grab the handouts that I was handing out just before the break, it looks like this. Okay, inverse trig ratios like that. If you don't have it, I will be posting it